Hello everyone, welcome to another video lecture on the topic triple integration. Well, this is the last video on multiple integral and in this video I'll discuss the problem from tutorial sheet and we'll see the working procedure for triple integration and of course its geometrical significance. Well, if you recall how double integration was evolved from single integration, in similar fashion we'll discuss the triple integration. Have a look into this picture. You will see that a single integration was for a function of one variable and you will get an area under the curve. You integrate in this case from point A to point B. From within a line you integrate, single integration. Again, and in case of a double integration, you will have a function of two variable f of x, y. And here integration region is not a line, but here is some region. Over here it is a square. You may not have a square, you may have other two-dimension form of the region, and after integration you will get a volume enclosed over here, which I have already discussed. Now definitely in case of a triple integration, you will have a region of integration as a volume itself. So here is, suppose this block, this block, if you consider, this is a domain of integration. Okay, we'll integrate over here. Now in case of single integration we get area, in case of double integration we got a volume. And what about triple integration? Because the region itself is a volume over here. Now in case of triple integration you may not get area, length or volume like that. You may have some other result which we can discuss later on. Now there are some of important point to note down, that single integration you integrate from point to point. This is very important for solving the problem. So single integration is from point to point, A to B. Double integration from one curve to another curve like that, which we have already discussed. Over here, triple integration is taken over some region. So in order to cover region, we have to integrate it from one surface over here, suppose this plane, to another surface, which is at the back side of the cube. If you recall, if we integrate or if we perform a double integration over unit function, then we'll get a volume or we'll get an area. You can pause the video and go back to the double integration topic and see how or what was the formula for finding an area using double integration, not using single integration. Okay, similar fashion we can use a triple integration to find the volume. So here is a formula for finding the volume using triple integration. As I told you, if a function is unit function, you will get a volume. If a function is not a unit function, you may not get a volume or you'll get something else. Okay, this is one of the application of triple integration, to find the volume by using triple integration. So here is a formula for in case of a cylindrical coordinate system, and this in case of a spherical coordinate system. So you can understand from this, I have considered here Cartesian coordinate system. Suppose this yellow color region is the volume which I want to find by using triple integration. Then here's a formula. You have to integrate a small dv. If you consider this, dv is actually dz dx, dx dy and dz, and if you integrate over this region, then you will get a volume. Well, we'll see through a problem how to set this limits, and this limits are important here. So we'll see with an example how to set the limits for triple integration. So let us consider a problem from tutorial sheet to find the volume bounded by cylinder and plane. These two planes are given, and we'll see another problem later on. Now to find the volume using triple integration, we just have to integrate a unit function as we did in case of a double integration to find area. So for using triple integration, we'll find a volume by integrating unit function 1 over dv. Now the first thing we have to understand is we have to understand this figures or the region. So in order to see how this region will look like, I have drawn using some mathematical programming. I have plotted the graph and it looks something like this. Over here we have a cylinder, x square plus y square equal to 4. So z function is not mentioned, that's why it look like a circle, but when it is in a 3 dimension it is a cylinder actually. But we have other two plane, that is z equals to 0 plane. Over here this blue, light blue color plane is z equals to 0, and y plus z equals to 4 is this plane. So we have to find the volume. These are the same figure from two different direction. So we have to find the volume enclosed in this region. So all we have to do is integrate the function within this region. So have a closer look from another angle, something like this. This plane is z plus y equal to 4, and these are all real-time graph. Like, these are not an approximation, these are exact the graph which the equation shows. Okay. So over here is a solution. We'll see one by one. The first thing is to understand the limit. Now how do we progress in case of a double integration? From one curve to curve, then from point to point. You can pause the video and go back and check double integration. The similar fashion we'll do. Now we will advance further. Before integrate from curve to curve, we have to first integrate from one surface to another surface. So have a look. In case of a z direction, if I want to integrate it first, z vary from this plane, z equals to 0 plane, up to this ceiling plane over here. Like, you can imagine the z equals to 0 up to this roof, which is another surface where the value is y minus 4, because the plane equation is z equals to y minus 4. So from z equals to 0 to this. Now once this integration along z direction is done, you have to come to the flat surface over here. That is in case of 2 dimension. Now vary y. Now take your time and try to understand. This is not difficult. In case of y, now imagine there is no this 3-dimension figure, only the circle is present. Then what will be the integration in y direction? So this is x-axis and this is y-axis. Okay. So in y direction, it will vary from this particular portion of the curve up to this portion of the curve. That is, if you imagine that previous double integration problem, you can imagine that arrow moving from this point to this point, this point to this point, and so on. So what is the equation, or what is the value of y on this curve? Y equals to negative of under root of y 4 minus x squared, because the equation of circle is this. So from here you can get the value of y. And what is the value of y on this half? This is a positive half of y, so value is plus of under root of 4 minus x squared. So that these are the limits. Now once you are done with the curve to curve integration, now all you have to do is from point to point integration, and of course x here vary from minus 2 to 2. If you have some confusion on this limits, it's better you go back and check a double integration limit technique, how to set the limit in case of double integration. Now further, I don't want to discuss this because this is same as what we did in case of double integration. Integrate with respect to z, substitute the limit, integrate with respect to y, substitute the limit, and then integrate with respect to x. You will get this as a solution. Okay. Now let us have a look into, that is, find the volume of ellipsoid. Now in this case also I have tried to plot the figure or a graph for this ellipsoid, and we have to find the volume of that ellipsoid. Well, let us first identify the region bounded by this ellipsoid. Now do you know what is ellipsoid? If you remove this 3-dimension portion, that is z-axis, then it is an ellipse. Now ellipsoid is a 3-dimensional version of ellipse. Again I have tried to plot the graph and it looks something like this. Now these are two same figure again, just to make you understand. I have from two different angle. Well, over here, this let us not first focus on this black arrow. This is just to make things visible. I have plotted them. Now we have to find the volume enclosed by this ellipsoid. Now how to do this? Now in this case, in order to find the volume of total ellipsoid, we'll use the advantage of the fact that ellipsoid is symmetry. So total volume we can find the 8 times the volume of a first octane. So here is a full volume. Here I'm using a word octane because it's a 3-dimension figure. This is first octane, second, third, fourth, and there are 4 more below z equals to 0 plane. So we'll find the volume only on the first octane and we'll multiply it by 8. We'll get a total volume. Well, if you wish to see ellipsoid only in a first octane, it will look something like this. Okay, this is what we are going to find. The volume of this region we are going to find out. Now the integration technique is exactly same as what we did in case of the previous problem. First you integrate in z direction. Over here I have denoted the integration in z direction by these arrows. Only few arrows, there may be more than this. So from where to where we'll integrate first. Let us see how to cover up this region. Now we will cover the region. So volume of the first octane, this is not the total volume, this is a volume only on the first octane, will look something like this. So over here z equals to 0 plane, this plane, up to this ceiling. Ceiling means this region, I mean this surface, not region, this surface. So what is the value of z on this surface? From here you can get it. So z will be equal to c under root of this quantity. You can pause the video, do a hand calculation and get all the terms one by one. Do not just assume. Now once you are done with this integration on in this direction, next is to integrate on 2-dimension plane now. Okay, now this is exactly same as the double integration problem. Now here is a portion of ellipse, now it is ellipse on 2-dimension plane, that is z equals to 0, it will be an ellipse. So this curve, if you can follow this cursor, whichever curve I am trying to show it to you, it's a portion of ellipse in first quadrant. Take it easy. This particular curve is a portion of ellipse on the first quadrant only, and we have to integrate, and in order to cover up the region bounded by region, now it is a 2-dimension region bounded by this x-axis, y-axis and the portion of ellipse on the first quadrant. So how will you integrate? Now you will integrate in one direction first. So I have chosen here to integrate in y direction first. So y direction, how it will happen? Y direction, in y direction integration will be done from this particular line to in this direction, in y direction, so up to this curve. Well, I'm going slow here because this is a point where you have to understand. You are already done with z integration. Now we are integrating in y direction, but in 2-dimension plane. Okay, so y direction integration arrow should be headed in this direction, right? One arrow, then again from this curve to this second arrow, and there will be infinite number of arrows. Arrows not having mathematical significance, just to understand the direction of integration, that's it. Well, what is the value of what is the value of y on this line? On this line y is equals to 0. You can see the lower limit of integration over here. And what is the value of y on this curve? Value of y on this curve is this. How will you get it? Because the equation of ellipse is this without this portion. From here you can get the value of y. And finally, once you are done with this integration, you just have to collect those horizontal strips from where to where? From 0 to a. Well, you can pause the video again and go back and check. If you have a doubt, you can go back and check the integration technique in double integration. So let us have a short revision. How do we cover the region? We'll integrate in z direction. Once we are done in z direction, then problem will become 2-dimension problem as if it is a double integration. Then perform that double integration. Well, if you do so, here is a solution. First integrate with respect to z. Integration is easy, only z. Substitute the limit. Over here you may get confused, but it is not difficult. Integration look like it is a difficult integration, but it is very easy and straightforward integration. You will see this. Well, I have substituted here b under root of this quantity equals to t. Now this is not a substitution for integration. Please keep it in mind. This is, I just want to reduce the term. Well, my integration is with respect to y, so whatever is it in terms of x are all constant. That's why I want to keep this particular term 1 minus x square by a square under root of this whatever term I have mentioned here as some constant, say t. T is here constant. Then my integration will become x equal to 0 to a. You can see this. Y will be equal to 0 to now t. And this particular quantity, do some simplification, you will get this. Now this integration, you can use a formula to integrate this with respect to y. it is integration of a square minus x square integration. So here is what I have used the formula, and substitute the value from 0 to t, integration will reduce to this. Now this again t is just a constant, I am substituting the value of t over t square from this, then it will be this much. Okay, all the constant pi by 4 and whatever constants are there, I have kept it outside, and here is what you will get after substituting the value of t. Now finally the integration is in terms of x only, then do the integration, substitute the value, you will get this as a integration value. Well, integration I am not going to discuss. In case of any problem occur in this integration, you can contact me individually or maybe in a group, I can explain it again, but I first want you to explore the integration technique. Now to get a total volume, then that is 8 multiplied by the given 8 multiplied by obtained volume, we will get the total volume as 4abc pi by 3. So these are two problems which we covered from our tutorial sheet. Now let us have a look into one extra problem which I will just discuss the outline, and I want you to solve the problem. So here is another problem. Find the volume of a tetrahedron. You can pause the video and check what is tetrahedron. Bounded by plane passing through 3 points ABC and the coordinate plane, and so and so. Now you can see the figure over here. This I consider it as a figure 2. This is a tetrahedron. One plane is there passing through point ABC. You can construct this plane, and we have to find the volume enclosed by this plane, and of course 3 more planes, those planes are coordinate planes. Well, so how to cover up this region? I mean, this particular volume is our main concern. We will get the volume of this tetrahedron. So here is another figure which I have bought it in order to understand the integration part later on. This particular shaded region is over here. Now you will see that this integration will look something like, okay, here you can just pause the video and go through this, how this particular figure has been plotted, and you proceed in order to solve. So here is the first integration direction. We'll first integrate along z direction from the plane z equals to 0 to, you can guess what will be the upper limit in z direction. Z equals to this 3 minus 3y and this particular. So how we get this is from the equation of a plane, okay, the value of z over there. Once we are done in this direction, then integration has to be done in y direction. So y direction, it will vary from y is equals to 0 to this y equals to 2 minus 2x. Well, intentionally I am not going in detail. This is a simple problem I want you to figure out. Now till this time we haven't bought the integration form over here, because I want you to work on, pause the video and try to write down the limits for integration, and later on you can check it with the integration which will appear on your screen. So here is the integration. So volume will be equals to 0 to this, then integration in y direction from this to this, and from x direction this to this. Now this integration technique I don't think I have to discuss. Substitute the value and integrate it, you'll get volume as 1. You can again pause the video and try to, if you landed up with wrong integration limit, pause the video and try to set up the limits on your own, so that it will be very, very helpful for you to understand the problem. So what are the important notes in case of triple integration? First, you integrate from one surface to another surface. It could be in any of the direction, but all the problems I have chosen here was in z direction first to make it easy. Once you are done with z direction integration, now problem is as if a 2-dimension problem, that is double integration problem, 2-dimension problem. Now you can pause the video or you can go back and check the 2-dimension integration, that is a double integration, how to set up the limits, then proceed as in case of previous one.